Let's talk about why object-oriented programming, or OOP, exists in the first place. At its core, it solves the problem of scale in software development. When most beginners start coding, they write what we call procedural code. This functions essentially like a simple recipe. You just tell the computer to perform step 1, then step 2, and then step 3. While this approach works perfectly fine for small, isolated tasks, look at what happens as systems grow. The code becomes a tangled, unmanageable web of dependencies for complex systems. To put this in perspective, consider a banking application. If this bank has 10 million customers, you absolutely cannot write a unique, distinct set of instructions from scratch for every single person. It is physically impossible. OOP provides a beautiful solution to this. Instead of repeating yourself, you write a single blueprint or template just one time. Then you use that single blueprint to generate as many individual copies as you need. Each copy functions as an independent entity called an object, carrying its own specific data while following the strict rules defined by your blueprint. To really visualize the relationship between a class and an object, I love the analogy of a cookie cutter. This cookie cutter right here represents the class. Notice that it's not a cookie itself. You can't eat it. It merely defines the shape and the boundaries. But you use it to create something tangible. These individual cookies produced by the cutter are your objects. From one single cutter, you can stamp out an infinite number of cookies. Crucially, these objects are completely independent from one another. If you decide to apply pink frosting to this first cookie and blue frosting to another, changing the first one has absolutely no effect on the second. When we program in Python, your class is that master template, and the objects are the individual instances created from it. Now, let's look at how this process actually works in code by following 4 logical steps. First, you write a class which serves as your master blueprint. Second, inside this class, you define 2 critical things. You define the data or attributes that the entity will hold, like a name or balance, and you define the actions it can perform, such as depositing or withdrawing money. Third, you perform an action called instantiating the class. That's simply the technical term for taking that blueprint and creating actual physical objects in the computer's memory. Fourth, once created, each object remains totally independent. For example, modifying Alice's balance to 1000 does not alter the data in Bob's object, which safely stays at 500, even though they were generated from the exact same class. To sum it all up, a class is the master plan, an object is the tangible result of that plan, and every object operates securely in its own space. Next, we'll dive right into the code to see exactly how to write this blueprint for a bank account and bring it to life.
Let's see exactly how object-oriented programming solves the problem of scale using this bank account example. We can start by looking at this single blueprint on the left, which we call our class. This bank account class defines the core requirements for every single account in the system. It specifies that every account must have an owner name, a balance, and a way to show that balance. Think of this as the master template. There is only one of these blueprints. Now, when we actually need to create an account for a real person, we instantiate or build an object. These 3 boxes on the right are the actual objects, the real things created from our blueprint. Notice that while they all come from the exact same bank account class, their internal data is completely unique. For instance, this first account belongs to Ravi Kumar with 50,000 rupees. The second account belongs to Priya Sharma with 75,000 rupees. And the third is Arjun Singh's with 30,000 rupees. This perfectly illustrates how one blueprint can manage infinite unique objects. Now, why is this so critical in the real world? Imagine a massive institution like the State Bank of India, which manages millions of active customers. If a developer tried to build this system without OOP, they would be forced to write separate variables and logic for every person who opens an account. For millions of customers, that is a structural impossibility. It's just an unmanageable amount of code. But by building the system with OOP, the developer only needs to write one single bank account class. The core logic remains exactly the same for everyone. When a new customer signs up, the software simply creates a new object from that master class. This allows the bank to handle millions of users seamlessly without the developer ever needing to rewrite a single line of code for new individuals. To actually build this powerful blueprint in our code, we'll need to understand how to translate these concepts into specific Python syntax next.
So how do we actually write this in Python? We start by defining our blueprint. Here we use the keyword class bank account. Inside this class, there is a very special function called init. We call this the constructor. Why? Because it runs automatically the exact moment a new object is created, setting up its initial state. Notice this word self in the constructor. In Python, self is incredibly important. It refers to the specific instance you're creating right at that moment. So when we say self.ownerName is equal to ownerName, we are telling Python take the name we just gave you and attach it directly to this specific object, not any other. Below that, we define a method named showBalance. A method is just a function that lives inside a class. It defines what an object can do. Here, its job is simply to print the balance of whichever object it is called on. Let's put this blueprint to work. We create two separate objects here. We have account 1 for Ravi and account 2 for Priya. Now watch what happens when we use our method. If we execute account1.showBalance, the system knows to look at Ravi's object and it outputs Ravi's specific details. But if we execute account2.showBalance, it looks at Priya's object and outputs her unique details. They are using the exact same method code. But because of that self keyword, they access entirely different data. To summarize these core rules, init method sets up the starting data, self ensures the data stays logged to the correct object, and methods operate using that individual object's data. Let's do a quick knowledge check. First, what's the difference between a class and an object? Think of a manufacturing plant. The mold is the class, the blueprint, the actual car part it stamps out is the object. Second, why use OOP for a banking app? It gives us reusable code and makes maintenance much easier. Third, remember our cookie analogy? The frosting color is an instance variable. It's the data that makes each individual cookie unique, even though they share the same base structure. Now it's your turn to practice. I want you to create an employee class for an HR system. Your requirements are to store the employee name, department, and salary. You'll need to write an introduce method that prints these details. Then create 3 separate employee objects and call that introduce method for each one to see how the unique data is handled. By grasping these concepts, you've made the fundamental leap from writing simple linear code to designing reusable blueprints. This is the true power of object-oriented programming. You now have the skills to manage vast amounts of unique data, automate object creation, and build a robust foundation for scalable, real-world systems.